Hi guys, thanks for watching the video. Right now I have two matrices on my board. Okay, we're going to call this one number 1 and this one number 2. Okay, let's activate our prior knowledge and let's think. What shape do we make to see what dimensions these are? Okay, I'm going to give you about 5 seconds. What shape? Okay, so if you said an L, you are correct. So we make an L like this. So we know this one is a 2 by 3. We know this one is a 3 by 2. So let's think about it even more. Can we add or subtract these two matrices? About 5 seconds. So you said no, you were correct because they do not have the same dimensions. This one has, even though they both have 2's and 3's, you cannot add or subtract these. But would you be surprised if I could told you that you could multiply them? So here's a trick that's very important that we really think about this and look at this one to see if we can multiply them. So I wrote my two matrices like this next to each other. If these are the same, are equal to one another, then you can multiply them. And then these don't have to be the same, but if these will tell you what the next matrix will look like. So you can make your L, because we know this is equal to one another. And you know that when you multiply these, it's going to be a 2 by 2. Okay, so let's go ahead and let's do another problem real quick to see if we can multiply these together. I'm not even going to write out or draw my matrices. I'm just going to write the dimensions since we already know how to find the dimensions on our own. So we're going to have a 3 by 4 and a 5 by 3. So yet again, I circle my inside numbers, but I know that these are not equal, so I cannot multiply them. But if I created matrices like this, I circle the insides, and they are equal to one another. So when I go like this, I can make my L, because then I know it'll be a 6 by 3. So this one's going to be really, really long, but this is not going to be very long, but the vertical way is going to be long, but not the horizontal.
Let's say that we've got two matrices, and I'll just, for simplicity, I'll start with two 2 by 2 matrices. So let's say that this first one right over here is 2, -2, 5, and let's say 5 and 3. And then I have this matrix right over here that it's also going to be 2 by 2. And let's say it's -1, 4, let's say 7, and -6. And what I want to go through in this video, what I want to introduce you to is the convention, the mathematical convention for multiplying two matrices like this. And I want to stress that because mathematicians could have come up with a bunch of different ways to define matrix multiplication. But the convention that I'm going to show you is the way that it is done. And it's done this way, especially as you go into deeper linear algebra classes or you start doing computer graphics or even modeling different types of phenomena. You'll see why this type of matrix multiplication, which I'm about to show you, why it has the most applications. But I really want to stress, this is a human construct. Humans have found defining matrix multiplication the way I'm about to show you to be useful. So let's just think about how this could be. And once again, I want to stress it's a human construct. There's several ways that you could have thought about multiplying two 2x2 matrices. You could have done it the same way that you add matrices. When you add matrices, both matrices have to have the same dimensions, and you just add the corresponding entries in the matrices. So why don't we, one convention could have been, why don't we just, for a product right over here, why don't we just multiply corresponding entries? So 2 times -1 would put a -2 here. -2 times 4 put a -8 here. That's how we did addition. We added corresponding entries, but that is not the convention for multiplying matrices. That is not the standard convention. The standard convention for multiplying matrices is we're essentially going to take, to get this top left entry right over here, we're going to take the product of this row, of that row, with this column right over here. Now, what does it mean to take the product of a row and a column? And if you are familiar with vector dot products, this might ring a bell, where you take the product of the corresponding terms, the product of the first terms, products of the second terms, and then add those together. And so that's essentially what we're going to be doing. We're going to be taking the dot product of this first row and this first column to get this top left entry right over here. If the word dot product makes no sense to you, I will show you what that actually means. So, and actually let's get some more real estate here, just so I think it'll be useful, especially this very first time that we attempt to multiply matrices. So this top left entry, it's going to be 2 times -1. So 2 times -1 plus -2 plus -2 times 7. Plus -2 times 7. So notice I took the product, first entry in the row, first entry in the column, those two products, then the product of second entry in the row, second entry in the column, that's right over there, and then I added them together. And that's essentially taking the dot product of this row vector and this column vector. If that doesn't make sense to you, if you're not familiar with vectors and dot products, don't worry about it. We just took the product of the first entry, product of the second entry, added them together to get, this is going to give us some number, and we'll calculate that in a few seconds. But let's think about the other ones. So to get this entry right over here, we're going to take the first row from this matrix and the second column from this matrix. And that kind of makes sense because we're still in the first row, but we're in the second column of the first row right here. First row, second column. So it's going to be 2 times 4, 2 times 4, plus -2, plus -2 times -6. And at this point, I encourage you to pause the video, seeing what you just saw. See if you can complete this. See if you can figure out the bottom left entry and the bottom right entry. And I'll give you a clue. It has something to do with this second row here. So I'm assuming you've given a go at it. Now let's just power through it together. Sometimes matrix multiplication can get a little bit intense. So we're now in the second row. So we're going to use the second row of this first matrix. And for this entry, second row, first column. Second row, first column. 5 times -1. 5 times -1 plus 3 times 7. Plus 3 times 7. And then finally, we're in the home stretch now. To get this bottom row, second column, or second row, second column, we multiply this row essentially by this column right over here. So it is going to be 5 times 4, 5 times 4, plus 3 times -6, plus 3 times -6. Now, what does all of this simplify to? So this is going to be equal to, let's see, so -2 plus -14, that's going to be -16. That right over there is -16. Then we have 8 plus 12, so that's going to be 20. And then we have -5 plus 21, which is going to be 16, positive 16. Did I do that right? Yep, positive 16. And then finally, you're going to have 20 minus 18. So that's just going to be 2. So the product of these two matrices, we deserve a little bit of a drum roll at this point. When we multiply this 2 by 2 matrix times this 2 by 2 matrix, we are going to get -16, 20, 20, 16, and 16 and 2. And we are done.
Okay, guys, so this is going to be talking about what we should look for when we're reading story problems because sometimes we have difficult doing that. So I'm going to read the story problem real quick. The student council was selling flowers for Mother's Day. They bought 200 roses for $1.67 each, 150 daffodils for $1.03 each, and 100 orchids for $2.59 each. They sold the roses for $3 each, the daffodils for $2.25 each, and the orchids for $4.50 each. Okay, so as I read that, I kind of was thinking to myself, what am I hearing a lot of? Well, I'm hearing a lot of the names of the flowers. So I know that one of my matrix labels should be flowers, and then an element will be a rose, daffodil, and orchid when I set up a matrix. And then the other one side would be the price. So that it doesn't matter where you put them as long as you are consistent. So, but I also need to make sure that my roses match up with my $1.67, my daffodils $1.03, and my orchids the $2.59. So when you're reading these story problems, you really need to make sure that you are seeing what's happening the most. What are they talking about the most? So we don't even care that, okay, so the student council is selling flowers for Mother's Day. That's not important. But what is important is 200 roses for $1.67 each. So if I were you, I would just highlight that. And then highlight each section that is similar to that. It's a trend that you'll see a lot in story problems.